For sample problem number 2, there is a toy car that rounds a smooth banked turn at a constant speed. The radius of the turn is 10 meters and the bank angle is 30 degrees as shown in the illustration. So this is the 30-degree angle. Find the magnitude of the normal force and the speed of the car. All right, so as this car goes around the circle, the center, so here's its headlights, here's the top of the car, here's where your person would be driving your car, so you kind of get a better idea of what's happening. The center of the circle is going to be straight sideways. It's not up or down, it's not parallel to the surface, because over here the car would be driving away from you, like this, where you see the tail lights in the back of the car. And so the center of the circle would be right here. So that means that we need to make sure that the horizontal axis is towards the center of the circle, which means that our x-axis is going to be in this direction, which means then that my y direction is going to need to be this direction. And then I'm going to draw my force diagram on this. I could draw a free body diagram as well, but I would like to just look at the forces for the moment. So I'm going to have gravitational force going straight down from my car. The surface of the hill is going to push up perpendicular to the surface of the hill, which is going to be that direction. And then if there was friction, it would be parallel to the hill in this direction. But in this problem, it tells me that it's a smooth bank turn, and whenever you see smooth, you should think, that means that there is no friction. So in this case, we only have gravitational force and normal force to worry about. So what I want to do now is I want to do my net force equations in the x and y direction. So the sum of my forces in the y direction, I only have Fny, so the y component of my normal force. So here would be my x, here would be my y, or I could draw it this way. Here's my y, and there's my x. And then it would be minus my gravitational force, and it would be all of the gravitational force because it's all in the direction of the y-axis that I've identified. My car is not accelerating into or out of the hill, so I know that my acceleration in that direction is 0. So I'm going to write equals ma, but my acceleration here is 0, so that'll be 0. And then for the x direction, the only thing in the x direction is the x component of my normal force. And that is towards the center of the circle. So there is an acceleration because it is going in a circle. And that's called the radial acceleration because it's going in the direction of the radius of the circle. And so if this is my radius here, then it's going to accelerate in that direction towards the center of the circle. And if you remember, the acceleration to go in a circle, or my radial acceleration, is v squared over r. So what I would like to do next is put in a few more details for each of these. So I'm going to substitute in for Fny and Fnx. But I need to be able to identify what my angles are. So if this is my triangle here, this is 30 degrees, that makes this angle 60. And then I notice that this is a 90-degree angle. Because that is a 90-degree angle, then this has to be an angle of 30. Then the angle between the normal force and the hill, so between here and there, has to be 90 degrees by definition because the normal force is always perpendicular to the hill. So if this angle here is 30, then that means that this angle is going to be 60. And then this angle here would be 30. Because between the x and y axis, it has to be 90 degrees. So, because this is our angle that we're given, I like to try to use that one in the problems. So I'm going to have my normal force in the y direction, so that's this, Fny. and that's adjacent to the 30 degrees here. So to clarify, I'm going to use this triangle when I'm doing FNX and FNY, so that way you guys can kind of see where I'm at. So FNY is my Fn times cosine of 30 degrees. And then Fg is equal to mass times g. And then this will be equal to 0. And then for my sum of my forces in the x direction, I'm going to have Fnx is going to be this side here. That's opposite the 30, so that makes this side Fn times sine of 30 degrees. And I could use Fn times cosine of 60, and that would also be the same thing. So don't worry about it if you use something a little bit different. And then this will be equal to mass times the acceleration to go in a circle. I'm going to go ahead and put in v squared over r. My radius is 10 meters, so this r is 10. And that's all the information I have. All right, so we are going to now try to find the normal force and velocity of this thing. And we have 2 equations and 3 unknowns. And I will just give you a heads up. Yes, I know we don't know mass, but there's an awful lot of times in physics where mass cancels out, disappears, doesn't matter, because of the physics of it. So I'm not going to stress about not knowing what the mass is. I'm just going to leave it as an m and know that at some point it'll probably cancel out. So just don't worry about it. Leave it as an m. It'll probably cancel out. All right, so I'm noticing that there's an Fn in both of these, and what I'm going to do is I'm going to solve for Fn in one of them and plug it into the other equation. And because there's a minus in this one for the sum of the forces in the y direction, I know that it'll probably be easier to solve for Fn over here because then everything will be one term. So I'm going to do Fn times sine of 30. And sine of 30 degrees is 0.5. So then I'm just going to divide both sides by 0.5 or multiply both sides times 2, which sounds a lot easier. So I'm going to multiply both sides by 2 because multiplying by 2 is the same as dividing by 1/2. And then I'll simplify. The 2 cancels out a 2 in the 10, so we're going to end up with mv squared over 5. All right, so now I have an equation for what Fn is, and I'm going to take this and I'm going to plug it in for the Fn right there. So now I'm going to rewrite this equation. So instead of Fn, I'm going to use mv squared over 5. And then I have cosine of 30. Cosine of 30 is equal to 0.866. I still don't know my mass. And then g is 9.8. So now I just need to solve. And one thing that I can look at and notice, and you'll get better at noticing this if you didn't notice it right away, is that there's a mass here, and there's a mass here, and there's only one addition or subtraction, which means that everything in this equation is times m. So what I can do is divide everything by m. So this m cancels out that m, this m cancels out this m, this 0 over m is still going to be 0. And so now I see, oh, look, that's not so bad looking now. And I can do then v squared times, and then I can do the 0.866 divided by 5. So I get 0.1732. I can add that 9.8 to both sides. And so then this will be equal to 9.8. And then I'm going to divide both sides by this 0.1732. And I get v squared is equal to 9.8 divided by that number. And I get 56.58. And then I just need to square root both sides. And I get a velocity of 7.52 meters per second. Super. So now I have my velocity, which is part B. So that's weird because I got that part first, but that's just the way some of these problems are. So don't worry about it. Just look at what you need to find. If you find one of them first and then you find the other one, that's totally fine. So now I need to find the magnitude of the normal force. And the easiest thing to do for that is to go back to my net force equations, to where I had most everything plugged in already. And so what I'm going to do is I'm going to notice, oh, look, I had an equation for normal force. Now, what's weird is I do not have mass. I'm not given mass. I would need mass to be able to find it, but I can definitely just take this right where it is and go, okay, my normal force is equal to mass, and I'm just going to leave it as m, times v squared, which I got the 7.52. And I want you to notice here we did have what v squared was. So I'm actually going to write v squared because we know what v squared was, and that'll give us one less thing to make our answer a little bit different. And so then, therefore, my normal force is mass times 56.58 divided by 5, which will be equal to 11.32 times my mass. And that's it.